Properties of electric field. So let's look at some of the properties of electric field. The first one, electric field lines start on the positive charge and end on the negative charge. So if we have a system of positive and negative charge, we can see that how electric fields are starting from positive and ending into negative. Second, field lines never cross each other. The reason for this is, let's say that the field lines actually cross each other. So as shown in the diagram, we can see that the field lines are crossing. So at the point of intersection, the test charge is going to have two different paths to travel. And that's not a possible case. And that's the reason field lines never cross each other. Let's look at the third one. The number of field lines leaving a positive charge or entering a negative charge is proportional to the magnitude of the charge. What does that mean? For example, we have a positive Q charge and positive 2Q charge. So we can see that the magnitude of the second charge is double the magnitude of the first charge. If we see the number of lines for the first charge, we have drawn 4 lines. And the second charge must have 8 lines because the number of lines must be proportional to its magnitude. So as it is double of the first charge, so the lines would also be double of the first charge. Let's see another example. We have positive 2Q and negative Q. If we draw 4 lines for negative Q, then positive 2Q must have 8 lines. So we can see how we are drawing it. There are 4 lines entering into the negative charge, and you will have 4 more lines which are going to exit. So let's see how many lines we have drawn here. So we can see that for 2Q we have got 3 lines entering into the negative. That means they are starting from the positive and entering into negative. And then we have 5 more extra lines. That means we have in total 8 lines. The fourth one, closer the lines, stronger the field. So by just looking at the density of the field lines, we can say whether the field is stronger or not. So in this diagram, if we want to check the electric field at point E, we can see that it will be the highest because the lines are closest, and that means it has highest density of lines. At point E, we have more number of lines which are close together. That means highest density of lines. Fifth point, direction of electric field is tangent to the field line. So if you want to find the field line at different positions in this diagram, let's say we want to find the field line direction, we are going to draw a tangent at the field line at point A. So we can see it is directed downwards because we know that field lines move from positive into negative. Similarly, we can find the field line at C by drawing a tangent at point C. So direction of E at D. Let's see, we want to find the direction of electric field at D. There is no field line shown there, so we have to first draw the field line. And then we are going to draw a tangent at point D. And we can see that the tangent will be pointing downwards. Okay, that's it.